This is The Hidden Life of Trees by Peter Wolben. We're in chapter 16, Carbon Dioxide Vacuums. In a very simple, widely circulated image of natural cycles, trees are poster children for a balanced system. As they photosynthesize, they produce hydrocarbons, which fuel their growth. And over the course of their lives, they store up to 22 tons of carbon dioxide in their trunks, branches, and root systems. When they die, the same exact quantity of greenhouse gases is released as fungi and bacteria break down the wood, process the carbon dioxide, and breathe it out again. The assertion that burning wood is climate neutral is based on this concept. After all, it makes no difference if it's small organisms reducing pieces of wood to their gaseous components, or if the home hearth takes on its task, right? But how a forest works is way more complicated than that. The forest is really a gigantic carbon dioxide vacuum that constantly filters out and stores this component of the air. It's true that some of this carbon dioxide does indeed return to the atmosphere after a tree's death, but most of it remains locked in the ecosystem forever. The crumbling trunk is gradually gnawed and munched into smaller and smaller pieces and worked by fractions of inches more deeply into the soil. The rain takes care of whatever is left as it flushes organic remnants down into the soil. The further underground, the cooler it is. And as the temperature falls, life slows down until it comes almost to a standstill. And so, it is that carbon dioxide finds its final resting place in the form of humus, which continues to become more concentrated as it ages. In the far distant future, it might even become bituminous or anthracite coal. Today's deposits of these fossil fuels come from trees that died about 3 million years ago. They looked a bit different, more like 100-foot tall ferns or horsetail, but with the trunk diameters of about 6 feet. They rivaled today's species in size. Most trees grew in swamps, and when they died of old age, their trunks splashed down into stagnant water where they hardly rotted at all. Over the course of thousands of years, they turned into thick layers of peat that were then overlain with rocky debris, and pressure gradually turned the peat into coal. Thus, large conventional power plants today are burning fossil forests. Wouldn't it be beautiful and meaningful if we allowed our trees to follow in the footsteps of their ancestors by giving them the opportunity to recapture at least some of the carbon dioxide released by power plants and store it in the ground once again? Today, hardly any coal is being formed because forests are constantly being cleared thanks to modern forest management practices. As a result, warming rays of sunlight reach the ground and help the species living there kick into high gear. This means they consume humus layers even deep down into the soil, releasing the carbon they contain into the atmosphere as gas. The total quantity of climate-changing gases that escapes is roughly equivalent to the amount of timber that has been felled. For every log you burn in your fire at home, a similar amount of carbon dioxide is being released from the forest floor outside. And so carbon stores in the ground below trees in our latitudes are being depleted as fast as they are being formed. Despite this, you can observe at least the initial stages of coal formation every time you walk in the forest. Dig down into the soil a little until you come across a lighter layer. Up to this point, the upper, darker soil is highly enriched with carbon. If the forest were left in peace from now on, this layer would be the precursor of coal, gas, or oil. At least in larger protected areas, such as the hearts of national parks, these processes continue today uninterrupted. And I'd just like to add that meager layers of humus are not the result only of modern forestry practices. Way back when in Europe, Romans and Celts were industriously cutting back forests and disrupting natural processes. What sense does it make for trees to constantly remove their favorite food from the system? And all plants do this, not just trees. Even algae out in the oceans extract carbon dioxide from the atmosphere. The carbon dioxide sinks into the muck when plants die, where it's stored in the form of carbon compounds. Thanks to these remains, and the remains of animals such as the calcium carbonate excreted by coral, which is one of the largest repositories of carbon dioxide on Earth, after hundreds of millions of years, an erroneously large amount of carbon has been removed from the atmosphere. When the largest coal deposits were formed, in the Carboniferous period, carbon dioxide concentrations were much higher, 9 times today's levels, before historic forests, among other factors, reduced carbon dioxide to a level that was still triple the concentration we have today. Where's the end of the road for our forests? Will they go on storing carbon until someday there isn't any left in the air? This, by the way, is no longer a question in search of an answer. Thanks to our consumer society, we have already reversed the trend as we happily empty out the Earth's carbon reservoirs. We are burning oil, gas, and coal as heating materials and fuel, and spewing their carbon reserves out into the air. In terms of climate change, could it perhaps be a blessing? We are liberating greenhouse gases from their underground prisons and setting them free once again? Not so fast. True, there has been a measurable fertilizing effect as the levels of carbon dioxide in the atmosphere has risen. The latest forest inventories document that trees are growing more quickly than they used to. The spreadsheets that estimate lumber production needs to be adjusted now that 1/3 more biomass is occurring than a few decades ago. But what was that again? If you are a tree, slow growth is the key to growing old. Growth fueled by hefty additions of excess nitrogen from agricultural operations is unhealthy. And so the tried and tested rule holds true. Less carbon dioxide is more lifespan. When I was a student of forestry, I learned that young trees are more vigorous and grow more quickly than old ones. The doctrine holds to this day, with the result that forests are constantly being rejuvenated. Rejuvenated? That simply means that all the old trees are felled and replaced with newly planted little trees. Only then, according to the current pronouncements of associations of forest owners and representatives of commercial forestry, are forests stable enough to produce adequate amounts of timber to capture carbon dioxide out of the atmosphere and store it. Depending on what tree you are talking about, energy for growth begins to wane from 60 to 120 years of age. And that means it is time to roll out the harvesting machines. Has the ideal of eternal youth, which leads to heated discussions in human society, simply been transferred to the forest? It certainly looks that way. For at 120 years of age, A tree, considered from a human perspective, has barely outgrown its school days. In fact, past scientific assumptions in this area appear to have gotten a hold of the completely wrong end of the stick, as suggested by a study undertaken by an international team of scientists. The researchers looked at about 700,000 trees on every continent around the world. The surprising result: the older the tree, the more quickly it grows. Trees with trunks 3 feet in diameter generated 3 times as much biomass as trees that were only half as wide. So, in the case of trees, being old doesn't mean being weak, bold, and fragile. Quite the opposite. It means being full of energy and highly productive. This means elders are markedly more productive than young whippersnappers. And when it comes to climate change, they are important allies for human beings. Since the publication of this study, the exhortation to rejuvenate forests, to revitalize them, should at the very least be flagged as misleading. The most that can be said is that as far as marketable lumber is concerned, trees become less valuable after a certain age. In older trees, fungi can lead to rot inside the trunk. But this doesn't slow down future growth one little bit. If we want to use forests as a weapon in the fight against climate change, then we must allow them to grow old, which is exactly what large conservation groups are asking us to do. That's the end of chapter 16. Next time we'll be in chapter 17, Woody Climate Control.